Okay, cool. I'm gonna just say a few words then, just to kick off. So, like I say, good evening or afternoon to all of you. Massive thank you to Ken for being with us. So, a bit of background and a bit of an immediate call for help first. So, for those of you that don't know me, my name is Barry Cranford. I'm the founder of the London Java community. So, I'm not a developer myself. I actually run a tech recruitment company called RecWorks. So here at RecWorks, we've been on a mission for the last 12 years to prove that recruitment can be a force for good in the industry beyond just getting people jobs. And that's specifically around learning, career development, mentoring, that kind of thing. So what we try and do is create groups and platforms to bring people together that want to learn and others that are happy to teach or happy to share. And that can be on a group basis like this evening and through groups like the London Java community. Or on a one-to-one level through our Meet a Mentor community. So what I want to help with this evening, every second Friday for the last 9 events now, we've been running an event which is under the Meet a Mentor banner is this part of this aspiring speakers group. So we have 5 lightning talks, generally new speakers, but sometimes we get a few experienced speakers. And this Friday we are short 2 or 3 people. So if you can speak this Friday, if you're interested, if you've got a talk or you think you could put something together, then please do reach out either on LinkedIn. I'll be on this event for about the next 2 or 3 minutes here. So yeah, feel free to let me know. Would love to hear from a couple of you. Anyway, everything we do, it's all powered by revenue from recruitment. So if you are currently looking to hire, your company's looking to hire, and you can make an introduction at all, or just bear us in mind, that'd be fantastic. Anyway, on to this evening. We've got Ken speaking tonight. So Ken's a Java champion, an Oracle Groundbreaker ambassador, and a Grails rockstar. He's the author of books Kotlin Cookbook, Modern Java Recipes, Gradle Recipes for Android, and Making Java Groovy. And he's a regular speaker on the No Fluff Just Stuff tour and teaches training classes in areas around Java related to Spring, Hibernate, JPA, Groovy, Grails, Gradle, and Android. Ken, over to you.
Well, thank you very much. Welcome, everybody. I'm glad you're able to make it. I do have the chat box open, so if you have questions or comments, please feel free to put them in there when you can. If they're really hard, I'll probably just skip them, but no, that's what, at any rate, never mind. I'm really glad to be here. I'm really, I want to be there in person. That's what I would love to do. Unfortunately, given our current situation, I don't think they'd even let me in the country anyway, so be it. The purpose of this particular talk is to discuss the 3 languages, Java, Groovy, and Kotlin, all 3, and to look at the functional features in all of them. So, I'm just saying right up front, none of the 3 are actually functional languages. They're all object-oriented languages that compile to Java bytecodes and run on the JVM. But they all have functional features that have been added at one point or another in their history. Java, of course, has been around, since the mid-90s. Groovy is probably the most mature of the non-Java JVM-based languages. Groovy, I think, really started getting established in the mid-2000s, roughly 2005 timeframe. And then Kotlin is a much more recent newcomer to the area, is managed by the JetBrains company, the company behind the IntelliJ IDE, as well as many other tools that are associated with it. And I think one of the biggest differences I'm going to show you between Groovy and Kotlin, for example, is that Groovy just has a lot more just because it's been around a lot longer. I mean, the approaches are different in all 3 languages, and we'll take a look at different features there. Plus, I have a few larger apps, somewhat larger apps to show you. And of course, at the end, as some of you may have noticed when I mentioned this on Twitter, I do have cat pictures involved. So please feel free to put comments in whatever you like, or to say whatever you want to say. And if it's something that takes too long to answer, I'm going to give you here. You can see my contact information. You're welcome to get in touch with me whenever you like. There's my last name, as was mentioned, is pronounced Kousen, like the relative, even though it doesn't look like it. There's my email address, homepage, blog, Twitter handle. I'm an older white male, so of course I have a newsletter. So it's all free. You're welcome to take a look or not. It's up to you. But what I do want to show you on this page at the very bottom is the GitHub repository that has all of the examples I'm going to show. So it's actually partly a demo of its own to show you that you can use Java and Groovy and Kotlin all in the same overall project, and they work just fine together. So just letting you know that's there. For versions, I should mention, I'm going to use Java 11 since that's the long-term support version at the moment. I'm not doing a lot of things that require Java 11, but I am using some of the, for example, the factory methods for creating collections, that sort of thing, list.of, etc. But mostly everything I'm going to show you would run just fine under Java 8. Groovy only requires Java 8, and I'm using Groovy 3, the latest version, although I think the current one is 3.0.5. And I'm going to use Kotlin, also the latest version there. I think it's 1.3.72, I think is the number, but I'll show you all those numbers inside the Gradle build file. So everything is compiled with Gradle. I have a bunch of test cases in there, and I'll show you the examples. So as they mentioned, they're the books that I've written in the past, and mostly what I want to show about that is that I have a long history of working with both Java and non-Java JVM-based languages like Groovy and Kotlin. So let me just dive right in. Oh, for what it's worth, also I'm a Kotlin certified training partner, and I would be the same thing for Groovy if there was such a thing. And of course for Java, you know, there's nothing officially that way, but of course I've been teaching Java related courses for years and years. Okay, so the fundamental thing is all three of these languages compile to bytecodes. So even though Groovy, for example, has some capabilities to do dynamic typing, if you will, everything is still compiled. Even the Groovy scripts are compiled down to bytecodes that run on the JVM. So the ability to interoperate has been designed in from the beginning. In fact, with Groovy, one of its design criteria was that it is about the easiest language for Java developers to learn because the syntax is very, very similar to Java and the integration is very, very easy. In fact, you can take almost all examples of Java code and rename the class as .groovy and it'll probably compile. It wouldn't be idiomatic, but it would work very likely. Kotlin, of course, is quite different from that, and Kotlin just came along later. But Kotlin has become the dominant language in the Android community. I mean, if you're going to do Android development, you pretty much need to learn it, which is one of the reasons I learned it. It was one of my drivers. That and the fact that there's now a Kotlin DSL for Gradle build files as well. So those both drove me to learn Kotlin, whereas Groovy I just liked, and I was working with Grails and Spock testing. That's the reason for the shirt, by the way, is I got a couple of Spock tests in there as well for many years. So Kotlin, Groovy, Java, they're all JVM-based languages. They all compile to bytecodes. None of them are, strictly speaking, what you would call functional language. They aren't Haskell or the Haskell version on the JVM, which is known as Frege, F-R-E-G-E. They're not purely functional languages, so they all have some limitations in that sense, but they all have functional characteristics and they work together very nicely. In fact, if you look at the Android world, you see that many Kotlin classes easily extend Java classes or implement Java interfaces because the Android SDK itself is still written in Java. So the idea of integrating with Java is very common. And in fact, for many years, I used to use Java for pretty much tools and libraries and basic infrastructure, things like the Spring Framework, and Groovy for pretty much everything else. So I just add a Groovy class in order to accomplish things that Java doesn't do terribly efficiently or easily, things like parsing XML or that sort of thing. Kotlin I still work with Java as well, although my Kotlin examples tend to be more just purely Kotlin. But again, because of their integration in the Android framework, it is quite normal to integrate Kotlin with Java, although I should say that Kotlin does also have capabilities to create JavaScript or to do multi-platform mechanisms. There's a lot of that around. I'm just not talking about any of that today. I'm going to stick with the so-called Kotlin JVM approach on all of that. So they're basically all object-oriented languages with functional features involved. All right, so when you start off talking about functional features, you have to start with the idea of Lambda expressions. Java introduced Lambda expressions in Java 8, of course, and the idea is that instead of introducing a separate class or interface for that, they decided to reuse interfaces in Java, specifically interfaces that have only a single abstract method. And then when you introduce the new syntax for Lambda expressions, you can assign them to references of single interface or single abstract method type interface. Now, one of the interesting things that comes from this is that when you see a Lambda expression, I'll show them very soon, that you often don't have to put in the actual parameter types. They are inferred from the context, and there's always a context. You can't have a Lambda by itself. It has to be either an argument to a method or assigned to a variable or a return type from some type. So there's always a context to help you determine the parameter types. This looks funny to a Java developer who's getting used to it, but it's been a while now, so hopefully they're fine. The other thing is that there's the distinction or the discussion as to whether these are lambdas or closures more properly. And a closure, I mean, I don't want to get into a formal definition because frankly, wars have started over less. But the basic idea is that a closure is, quote, closed over its execution environment. It's an expression that can see variables that are in scope and possibly even modify them. Java is mushy in that respect, which is probably not surprising for a language that has literally 25 years of backward compatibility issues to deal with. So Java, inside a Java Lambda, it can see local variables, but it can't modify them. The phrase that's often used is those variables must be final or, quote, effectively final, meaning you don't have to use the final keyword, but as soon as you try to modify one, the code will no longer compile. Now, Groovy, on the other hand, actually introduced a class called closure right from the beginning. And these are closures in the classical sense. I mean, there is a class called closure. It's got a call method. It has all the mechanisms you'd expect to see. When you're inside a Groovy closure and you're trying to access a variable that you don't see or call a method that you don't see, Groovy closures have a property called delegate, which will be searched in order to resolve dependencies like that. And in fact, that's part of the heart of how Groovy makes domain-specific languages, DSLs, by playing around with the delegate property there. Now, the other thing is that Groovy can access local variables and modify them, so it really is a traditional closure. Now, whether this is a good idea or not is a whole different issue. It's just that it compiles, it is legal in that sense. When Kotlin came along, Kotlin is very much, I mean, I don't mean this in a negative way. It's kind of a Frankenstein's monster because basically everything in Kotlin seems to have come from somewhere else. You could say, oh, okay, the closures look just like the ones from Groovy. The OO model looks very similar to that from Scala. It's very much of a, hey, they did a good job over there. They did a good job over there. Let's put them all together and make it work well as a unit. And that's what the feel of Kotlin often is until you really get used to it. You get some odd things like an Elvis operator, which is the limiting form of a ternary expression. And it's quite ironic because Kotlin doesn't even support ternary operators. So it's very, they don't need to, by the way. They have if statements that return a value, and that's the sort of thing I miss when I go back to Java. So all three languages have interesting features. Kotlin talks about Lambda expressions, however, and when you declare a variable type of type Lambda in Kotlin, you wind up seeing this syntax. So they didn't use interfaces. They didn't use a closure class or a Lambda class or interface. They actually write expressions of the form input types in parentheses and then an arrow and then the output type. And you can declare variables of that type. You can assign properties of that type. And if you look at the docs for Kotlin, that's what you'll see all the time to indicate you're dealing with a Lambda expression. Now, the funny part about Kotlin lambdas, oh, before I get to that, Kotlin, when you want to resolve, again, dependencies inside a Kotlin lambda expression, they don't call the property a delegate the way Groovy does. Instead, they have a receiver. And the way you build Kotlin DSLs, domain-specific languages, is by creating lambdas with receivers and going from there. So it's an interesting property, and it's an interesting contrast in how you build things. by the way, with Kotlin, you can in fact access local variables from within a Lambda and modify them. So really, by the definition I was giving earlier, Kotlin lambdas really are closures. They just call them lambdas. So I'm going to use the terms that each language prefers to use. Like in Java, we have methods. In Kotlin, we have functions. In Groovy, we have methods. But again, Groovy terms are going to be very similar to Java ones. And then sort of see where the trade-offs are and what you could do in each language. Now, Java, of course, when they introduced lambdas, also introduced the idea of method references and streams. And this is an interesting decision because what happens with Java, in fact, let me go to the code here to illustrate this. Incidentally, I am using IntelliJ IDEA for my examples. And the way I have the code organized, I know you can't see this, and unfortunately my magnifier doesn't work over Zoom. So I'll just tell you the way the code is organized is I have a source main Java and a source main Groovy and a source main Kotlin. That is somewhat of an artificial distinction. It's very possible to mix and match these things. In Android apps, the Kotlin code goes under source main Java, for example. And with Groovy, you can put Java code in source main Groovy, and the Groovy compiler will simply delegate down to Java and resolve cross-compilation issues that way very nicely. So I do have them separately, but it's not required that way. Now here's the Gradle build file that I was telling you about. You can see I'm using a Groovy plugin, which includes Java. This is the Kotlin JVM plugin, if you will. As I say, there's a Kotlin JS one and a few others as well. I'm going to be using IntelliJ, but I included the Eclipse plugin in case you needed to generate an Eclipse project from this. So again, here's the version of the version of Kotlin that I'm using. I also have the Groovy version down here is 3.0.5. I was going to go to the trouble to replace the Groovy all dependency with all the individual Groovy sections, submodules, and that seems to be a good idea. I just haven't gotten around to it yet. So I'm using the Kotlin standard library that compiles onto Java 8, even though I'm using Java 11. I did not declare in here anywhere that I'm using Java 11, so it's not strictly necessary. I have a few other dependencies in there, some stuff for coroutines and Google's JSON, and there's my testing libraries for Spock and the Hamcrest libraries, and all my JUnit tests will be run with JUnit 5 as well. So I run the tests in parallel. I compile everything to Java 1.8 or above, and that's the basic Gradle build. Now, what I was going to show you is that under Java, if I want to do a functional example, I have a nice simple map filter reduce example. Whoops, that's the Kotlin one. So the Java one is lambdas, or no, I think I want to show it under, oh, here. Okay, so just a trivial example here. For example, if I take a collection of strings built from a list like this, I can use the stream method to create a stream, and then all the methods I want come from methods on stream. And that's really interesting as a decision in Java, is that instead of adding methods like find all or map or filter to collections themselves, the decision was deliberately made to introduce this layer of indirection of using streams, a stream interface, and working with everything on top of that. Now, the benefit you get from that is that you are able to retrieve data from not just collections. It can be from a whole variety of sources and convert them into a stream and then do map and filter. Also, this way, the stream code can be lazy and short circuit. As an example of a lazy stream in Java, here's one I want to show you. Oh, I have this invoked from a test. So let me actually go to the test here. In fact, I have a Groovy Spock test, a specification in order to execute the test. So what am I trying to show here? Take a look at this highly contrived example. Actually, let me modify this example. And I will update the GitHub repository accordingly. This is a highly contrived example where I'm looking at the integers from 100 to 200, and then I look for the values that are divisible by 3 and then double them and retrieve the first element. So if you don't know about the laziness of Java streams, this looks highly inefficient. It looks like I do a modulus operation on 100 numbers. And then of course of the remaining a third of them, I double them all. And yet I only want the first one, and that returns an optional. That's why I have the or else there as well. Well, what you learn, of course, with Java streams is that each element traverses the pipeline element by element all the way through until it hits the terminal operation, and then you go through the next element. So if this one finds the first even number divisible by 3, this one allows me to show the actual print of, oh, I'm going to multiply by 2, I'm going to divide by 3, so I could see these all being executed one by one. And if I go to my spec here, let me execute it first of all this way, and the results are just 204, so there's nothing to print here. This should be very easy. Taking its time, I'm afraid, but it'll be pretty quick. There we go. So that worked. Whereas if I do it in a verbose fashion with the Java one, with a when and a then you'll see here that the printout shows the actual numbers here being right here, actually. In fact, this one, the Java one, showing, again, if I show you the code, it took 100 and said, are you divisible by 3? And said no, and therefore went to 101, and that wasn't divisible by 3, and 102 was. So then we entered multiply by 2, and you could see that, in fact, all I wound up with was with 4 calculations total. Whereas in the Groovy one of the issues with Groovy is that Groovy added the various map, filter, reduce type methods directly to collections. So this is an open range from 100 to 199, basically. And unfortunately, Groovy named their map method collect. I know that at the time they had no idea the Java people were going to reuse the name collect, but there it is. And their find first method is called find. And the problem with this approach is that down here, when I print each value, you can see I'm actually going through all the values one by one and wind up doing lots more calculations than the Java one did. And that would be bad, except for the fact that down here, this is Java stream code written in Groovy. And that's always something you can do in Groovy. If you don't want to do things in the way Groovy naturally has them, and you decide to take advantage of Java mechanisms or Java libraries, or in this case, lazy streams in this case, you just write the Java code. And in fact, this is one of the other differences I want to mention. In Java, let me show you the Java one again. In Java, Lambda expressions take the form of a variable and an arrow and then an expression. This is an expression Lambda. I could also do a block Lambda if I wanted to, but notice that in an expression Lambda, there were no braces at all in either of these. I could change it. That's one of the things IntelliJ could do for me, is I could say, let's expand the Lambda body, and now you see the return statement. I could even go ahead and see the parameter type if I wanted to, but that's really unnecessarily verbose in this sort of circumstance. Whereas in Groovy, and as we'll see in Kotlin, they wrap the entire closure in braces. So the syntax works from inside, and in fact, if you only have one argument to a Groovy or a Kotlin Lambda expression and you don't give it a name, the name defaults to the word it. That makes a lot of sense in a language named Groovy, which was created by native English speakers. Kotlin, of course, it comes from JetBrains. Most of the developers of Kotlin speak Russian as their native language. So again, they're using the word it there, which I'm assuming is simply, leveraging existing developer understanding. As I say, just pulling things from other languages and just reusing them. So there's just a very trivial example of Groovy and Java. And if I look in the Kotlin side here, I have a map filter reduce example here. And you can see that in the Kotlin, oops, I opened up a Groovy one. That's the danger here. So let me go down to Kotlin here. Here's my map filter reduce. And in this case, let me make that full screen. You can see, we'll get back to this idea of data classes. They have one wonderful thing here, which is this use of single expression implementations for functions, where instead of writing braces and having multiple lines in a return statement, if the entire implementation of your function is a single expression, then you could just use an equal sign at the end of the signature and write it this way. And there is subtle pressure on you to do something like that. Actually, you'll find that much of the standard library in Kotlin is written that way. But here's a map, filter, reduce example to give you a flavor of what Kotlin looks like. There are various factory methods for making lists, sets, maps, and arrays. Like list of puts together a collection. And then I have a map function here that will double them all, and then a filter which will look for the ones that are modulo 3 again. And in this case, I can invoke a sum method on it directly, and it works just fine. Now, again, that's probably more calculations than I needed, because I'd probably rather do the filter and then the doubling, but so be it. And you can see it's easy enough. Oh, this is what I was going to tell you. First of all, this is a variable assigned to a lambda, and this here is a variable assigned to a lambda where you see the actual syntax of a lambda expression in Kotlin. So if you want to see the data type of a lambda, that's what they look like. So here's a multiplier, takes two integers, returns an int. This is even, takes an int, returns a Boolean. This one is implicitly inferred from the, well, this is actually a predicate on the right-hand side. IntelliJ, of course, is showing me the data type automatically. And you can also use things like method reference syntax, which is similar to that from Java. This is implying that is-odd is in the current environment. Now, the other thing that Kotlin has is what they call top-level functions, so that you could write functions outside of a class. And these are effectively, from a Java point of view, what we would call static. And that's important because Kotlin doesn't have a static keyword. So they handle static in much the way that Scala does, with companion objects and things like that. And notice again, methods like filter and any and all these methods are implemented directly on collections rather than having to go through the stream mechanism. Now, the other idea here, I don't think I have it in this example, but the thing I'm going to show you in the slides is that if you want the stream type behavior where everything can be done lazily rather than operating on every individual element in a collection, Kotlin introduces sequences for that. So they, unlike Groovy, which could just say, well, Java uses stream, so I'll just write stream code in Groovy and it's fine. In Kotlin, you have to create a sequence, but then the behavior is exactly the same as it would be in Java. All right, so I have a whole series of examples with these things with Kotlin and Groovy and Java. Again, that's the idea of the single expression functions in Kotlin, very convenient there. But those things are all very familiar. And again, I mentioned something about the laziness as well, all being illustrated here. So with Kotlin, we have an as sequence method. There are actually several ways to make sequences, but one option is to use an as sequence method. And if I take a look in the Kotlin one, here's the idea of a lazy sequence here. So in this case, this is just doing that same demo I did before, where it doubles things and then finds the values that are divisible by 3. So this again is the open range in Kotlin. The map being done here is done on the Lambda expression that prints out the number and then doubles it. The filter here then prints out the number and modifies it. And I could simplify that, but I'm not at the moment, and grab the first one. And this time, if I run the, let's see, this is the one with the sequences. So these would show all the elements being doubled and then using the modulo function. Here, all I have to throw in is as sequence. And in my main function, you'll see that, again, I'm only dealing with a handful of values because each value is traversing the entire pipeline before you go on to the next value. So Kotlin and Groovy and Java all have this same or similar mechanisms to get the behavior you want on those. So here it is in the slides. Here's an example of a Java filter and a map and a reduce. Now, one other thing that's going to come up, and I'll show this as we go, in Java, the methods that you're expecting to be called map, filter, and reduce are in fact called map and filter and reduce. In Groovy, they have different names, which I'll get to in a moment. In Kotlin, they're the same names here. In this case, though, I'm using Lambda expressions in Java that fit one of the functional interfaces that were added in Java 8. Filter, for example, takes a predicate, map takes a function, and reduce here is taking what they call an identity value followed by a binary operator. So I'm taking two values here and I'm returning an expression, and all three of these are of the same type. So the accumulator, each individual value, and the sum are all of type, in this case, presumably integers, and therefore I'm doing a reduction operation. Now, Kotlin also, Java provides mapping methods like map to int or map to long or map to double, so that instead of using a stream of int, long, or double, I have an int stream, and therefore I have a sum method. So there are simplifications for some of these reduction operations there. In Groovy, unfortunately, the names are different. Now, find all, seems very intuitive. That's the filter method, if you will. And in fact, some people like this better than the name filter, because the filter method, sometimes you have to decide, wait a minute, is my filter only letting through things that pass the predicate or removing things that pass the predicate? And it's allowing things through that pass the predicate. Whereas find all, well, clearly it's find all such that it mod 3 is 0. The unfortunate one is collect, because collect is used here to produce a new collection by applying a closure to each element of the original collection. So it's sad that it's called collect, but there's your map function. And then instead of having a method called reduce, they call it inject, of all things. And there's your two argument inject. And both Groovy and Kotlin have the convention where if the last argument to a method is a lambda, you can put the lambda after the parentheses. So inject actually takes two arguments, the initial value or the identity value followed by the lambda. And this is exactly the same as before. Groovy also has duck typing where you can just invoke a method, and if the method is there in the result, you're fine. Groovy is the only language I know of that is optionally typed. I mean, Java is statically typed. Kotlin is statically typed. JavaScript is dynamically typed. All the types are determined at runtime. Groovy is the only language I know where if you say a type, then it'll accommodate that type. But if you say def, D-E-F, then you're saying I don't know or I don't care. And the compiler will let it go, and then we'll see what happens at runtime. I got to say, though, most Groovy developers I know use def sparingly. I mean, I'd say probably 90%, 80, 90% of all Groovy code doesn't use def at all, because the code is easier to read if you don't use it. It's easier for others to read, I guess I should say. It makes the compiler your friend. But there are certain cases where having dynamic typing certainly makes life easier, and Groovy gives you the option to do that. In Kotlin, there's the filter method, as you would expect, and the map method, as you would expect. Interestingly enough, Kotlin has two reduction operations, unlike Java, which uses reduce with either a binary operator or an initial value and a binary operator. In Kotlin, they use a fold method if you have the identity value, and use the reduce method if you don't. So they have a reduce method. If I used reduce here, I wouldn't be putting in the 0. And with a simple sum like this, it would be fine. I wouldn't need that. In the fold method, that value, which is supposed to be the identity, becomes the initial value of the accumulator. And then whatever you return from this expression is the next value of the accumulator on the next iteration. And value takes the values of all the elements of the stream as you go along. Again, there's a simplification in this particular case available. So all of them have the same basic methods. It's just the syntax is a little different. But the concepts are easy no matter how you do it. So if I convert it to a sequence, then it really is indistinguishable from a Java stream if you want. All right, now let me go a little bit beyond and start seeing things that you can do that are different in the languages from what you could do in Java. Now, one comment, because I'm going to need some helper classes as I go along. In Java, we have POJOs, and of course in Java 14, as a preview function, we have records. And records look like they're going to be really nice and very helpful. They automatically generate toString methods and equals and hash code. They're final classes. They provide the basic functionality. They have a builder syntax and allow you to access the individual elements and provide a constructor. It looks to be very slick. From what I gather, I think records are going to be a preview function in Java 15 as well, coming out in September. Maybe they'll be final in Java 16, I don't know. Groovy, however, has had pogos from the very beginning. And a pogo is just a plain old Groovy object instead of a Java object. And that means you get private attributes, public methods, a public class, the named argument or map-based constructor, generated getters and setters. And if you throw on an AST transformation, abstract syntax tree transformation, like canonical, then the compiler will generate at compile time toString methods and equals and hash code, that a tuple constructor and everything. So the AST transforms are used in Groovy to great effect to generate lots of very helpful code at compile time. Now, while writing an AST transform can be a little tedious because you're actually manipulating the tree, using them is trivial. You just throw the annotation on there and you're good to go. And in fact, AST transforms is one of the ways Groovy shows its maturity level, because when you look in the Groovy docs, there are many AST transforms available and many more added all the time. Some of the more popular ones, there's an @delegate transform, which implements the delegate design pattern. There's an @immutable AST transform, which is very useful in functional programming for removing all the ways to modify a class, for example. So very effective. And of course, one of the ones that gets the most press is compile static, because then if you know your code isn't using anything dynamic, you can optimize the compilation process and get really efficient bytecodes that way. So Groovy has these AST transforms to provide a whole host of features. And I'll show a couple examples of that later. But in Kotlin, I was kind of disappointed they didn't go with the name POCOs, you know, P-O-K-O for Kotlin classes. But at any rate, they went with something called data classes. They added another keyword, data, that goes in front of class here. And this is the entire class. There's no braces on this at all. You can add braces if you want to add additional methods, but this looks and feels like a primary constructor, and that's effectively what it is. And with a data class, then again, you get, well, this says getters and setters, but because these are using val for the keywords here, that means these are final properties, and therefore there are no setters that are generated in this. But you do get getters, you get toString, equals, hash code, you get a copy constructor effectively in the form of a method, you get component methods for what they call destructuring. You could assign an instance of a data class to multiple variables and have it split them into the individual parts. And there's some really nice features that come from that. So at any rate, that's not part of the functional programming aspect of it, but since I'm going to need some of those, I just thought I'd mention those as we go along. So if we look at what goes beyond the basic map, filter, reduce paradigm, you know, if every language that calls itself functional can do map, filter, and reduce, what else can we do? Well, closure composition would be one area. I'll show that. There's a term called memoization, which basically keeps track of previously computed values. There's the idea of tail recursion, where you can implement recursion and have a mechanism that automatically reuses stack frames so as not to use up all your memory. And then the whole idea of currying, so where you can have one function produce another. So here's an example in the Groovy world. So if I go to, let me close all these. So in my Groovy one, yeah, let me give you an idea here. Now this, let me go directly to memoize, for example. This is a Fibonacci calculator. So you put in a big integer, and if the value is 0, return 0, and Groovy will automatically interpret that 0 as of type big integer, so I don't have to cast it, I don't have to convert or anything. If n is 1, then I'll get back a 1, and else I'll delegate to the calculation of fib n minus 1 plus fib n minus 2. And of course, if you do that just as regular recursion, you're going to run out of memory very fast for very low numbers of n. Well, in this case, all you have to do is throw on this AST transform called memoized, and what that does is it automatically creates a cache for the results of the method. In other words, it will create a map basically where the keys are n here and the values are the computations for that n. And as long as what I'm dealing with is a pure function, which it is in this case, there's no side effects and there's no dependence on anything other than the argument, then storing those intermediate values becomes very, very simple. And I can use this for extremely high calculations. I think I've got a test here that runs this for, let's see, where's my Fibonacci one? Well, of course, for the first 10, naturally, but with the memoize, it's working. And I think I've got some that go absolutely nuts. Like here, I computed, this isn't the one I wanted. That's the tail recursive one. Any rate, I don't see the example that I wanted right at the moment, but I have an example where you can compute Fibonacci of like thousands or tens of thousands. And because it's basically storing all the previously computed values, you don't wind up overflowing the stack like you normally would. Here's the same thing written, if you will, as a factor, or here, not the same thing, but the same idea with a factorial program using the ternary operator again. And here's the idea of saying, oh, I'll test this by throwing in a sleep just to show if I run it the first time, it'll sleep a second, and the second time it'll return immediately. Now, another annotation or AST transform that's created in Groovy is this one called tail recursive. So the idea of tail recursion is that you have a function or method that's going to call itself, and you have one value or one argument that is the number you're trying to compute, and another that is essentially an accumulator. So the idea of doing factorial with an accumulator is saying, well, I want to compute the factorial of n. My accumulator starts at 1. The g here makes it a big decimal. I'm going to say, well, if n's less than 2, just return the accumulator. Otherwise, call factorial again with n minus 1, and the argument here is n times the accumulator. Now, you can write that algorithm even in Java. It's not difficult to write it. But the tail recursive annotation allows it to reuse the stack frames and therefore become very, very efficient. And once again, I can compute factorials of extremely high numbers without a problem because I'm not actually winding up writing this recursive call that has to go stack frame after stack frame after stack frame. It's very, very efficient. These are other examples of tail recursive functions that show up in the docs actually for Groovy. Also note typical Groovy mechanisms. You don't have to write a return keyword. The last evaluated expression is returned automatically. Values are converted into the proper data type. I wrote a G here on general principle. It's basically just documenting it. It's not like I have to do that. Groovy will figure it out. Now, Kotlin has something like that also. What Kotlin has, oh, I didn't show it here. What Kotlin has is a tail recursive keyword. So my tail recursive keyword is on this guy here. So let me go up to the top and show you the mechanism again. So first of all, this is adding up a bunch of elements using the fold function. Now this is overkill. There's a sum function that I could just use. But again, showing that if I have an argument, I use fold. And likewise, this is just printing out the values as they go by. But there's also a reduce function if you don't have an argument. So why they made two separate methods for that, I don't know. I assume that has something to do with Scala, but I don't know for sure. And then here is the Fibonacci calculation with a couple of interesting features that Kotlin provides. Now, first of all, Kotlin does something that Groovy does as well, which allows you to specify optional arguments here. So my Fibonacci function takes either one argument or 2 or 3. And the arguments could be the first 2 or the first and the last or all 3 or just the first one. So there's lots of overloads of this. And the problem is from a Java point of view, they don't have optional arguments. So if you throw on an annotation like @JVM overloads, now the generated bytecodes will have all the different overloaded approaches in there. And I can call this from Java with all the different methods. So the idea here is that I'm going to start off with a number, just call it with one argument, the Fibonacci number I want to compute. And it'll start off with A and B as 0 and 1. And when I look at n, we have this when operation that returns a value. That means this whole thing is a single execution, single statement, single executable implementation. So if if I have n is 0, then I return the first value A. If n is 1, I return the second value B. In other words, I invoke I invoke the Fibonacci calculation again, where n you subtract 1 and A becomes B and B becomes A plus B. And this little mechanism again is basically a recursive implementation that's really using an iterative mechanism. The tail rec keyword then lets this take advantage of all of the reused stack frames. So once again, I could run this for extremely high numbers and not run out of memory here. This is doing a similar thing with fold. And what I wanted to mention here is this idea with the underscore here is the idea of what they call destructuring. When I have a value and I assign it to multiple arguments and one of them I'm not interested in, I could just use an underscore to represent that argument if I need the positional argument there. So this is actually using another thing that Kotlin provides called an infix operation. The to function here actually generates what's called a pair, what a lot of languages would call a tuple. It's a collection of two values of any type, first and second, and I'm returning the second one of a generated pair. So this gets a little interesting. I don't want to go into the details of how this works, but it all works nicely, and you can always print out the values as they go along and make sure it's all working. So yeah, so at any rate, I have tests for all this, and it all works with big integers and big decimals, and it's really kind of neat. All right, another capability that I want to show you is what they call closure composition. Part of the motivation for functional programming is similar to the motivation for creating, say, the Unix operating system. You make a bunch of small functions and then you wire them together to do interesting things. Now, Java kind of has closure composition in the sense that in the functional interfaces that were added in Java 8, the ones under java.util.function, several composition methods were added. And here's an example of that. Let me show you that directly. So this is the combine, I have to spell it right. Here we go. So this is Java code where I'm basically saying, okay, I got a logger here and I made a collection that has some nulls in it along with some strings. And here are a pair of predicates, and I designated this a predicate of type string, even though I'm just looking for the non-null calculation. So I still have to pick a data type because it's on the left-hand side. This is something that goes with Java. So at any rate, my null filter is a method reference to the non-null function in the objects class. My evens calculation takes the string, computes its length, and sees whether it's an even number or not. Likewise, I have two consumers, one to use the info method on my logger and another to just do a print line to the console. So what you wind up with is I could take my strings with nulls here, convert into a stream, and do a filter with a short circuiting composite predicate. The null filter here is the first one, and there's a method called and in predicate that builds a composed predicate starting with the left-hand side and then adding in the second one. So they actually show this is a logical short-circuiting and that's been built right into the library. Of course, as you might imagine, there's an or, there's a not, there's a negate. Here we have and then, which is being used for consumers. So again, you can kind of see the good and the bad. They do have some of the composed methods that are needed, but they don't make it easy to build composition with arbitrary lambdas. The lambdas always have to be assigned to some functional interface, which always defines a single abstract method. Everything else has to be default methods or what have you. It's not so easy. I mean, they've got something, and again, with a language that has 20 years of backward compatibility, that's not bad. You know, here you can see the values coming out. There are the non-null even length strings. This is printed to the console, and then these are written through the logger. So there's your basic closure composition in Java. Now in Groovy, on the other hand, they introduced the right shift operator. So there's a completely different way to work with this. So in my Groovy one, you see here, I basically made two variables, one to add 3 and one to multiply by 2, and simply assign them to single argument closures. then the left shift operator here, I think I said right shift before. Anyway, the left shift operator here builds a composed closure, if you will. It just feels a little backwards to me. Basically, this thing will multiply by 2 and then add 3. So if I take 5 and double it, that will be 10, and add 3 is 13, and I always have to work it out in my head. See, here I'm writing them out individually. You can do the reverse composition with the right shift operator, and then you have to either assign it to a variable or wrap it in parentheses or something like that. And you could reverse it and everything. So Groovy actually does have closure composition if you decide you want to use that. Now Kotlin as well has, Kotlin doesn't have an operator for it, and they don't have a built-in method or function for it. Instead, they have write your own. Now, I took this example directly from the Kotlin documentation just to see how it would be done. And you see here, the idea is they made a function of 3 generic types, A, B, and C, called compose. And the first function converts a B into a C, whatever that might be. And the second function converts an A into a B. And the result will convert an A into a C. And how do you do that? Well, you produce a lambda where the single argument is used in this fashion, f of g of x. So in other words, this produced the compose function specifically for any function of 1 argument that returns a single value. So, or rather, in this case, it's returning, it returns a single value because I'm going to take the A type and convert it into a C. So the way this works is you could write a couple of functions here. There's my length function, here's my isOdd function, and then you can call compose with those references and wind up invoking that, like here, just filter with the odd length, which is saying first is odd and then get the length, if you will. Or rather, sorry, the other way. Get the length first, and then I only want the lengths that happen to be odd numbers, if you will. So when this is executed on 3 elements, I get back the outputs that are just of odd length, as you see here. So this is kind of done by hand, if you will, but because you have function arguments, you can build up this sort of thing if you want. And honestly, this one I could do with Java. I just have to use functions to do it. So I could write a compose method that had a couple of functions, but again, they already have some stuff in the function class in Java. This, by the way, is an example of a really interesting thing in Kotlin called a scope function. The idea here is also a function that has been added to every type using what they call, again, I can't magnify that, so I can't really talk about it, but it's an extension function that says, take whatever the result is and do something that doesn't modify the result, and then returns the result again. So this also print line, I've heard a friend of mine refer to this as also print line as my debugger, you know. Just again, another feature of Kotlin, and it also, if I hadn't mentioned it earlier, this would give me the chance to talk about the method reference syntax as well. So they all have it. Java's is kind of limited, but Groovy and Kotlin really go beyond, and Kotlin really has, or Groovy actually has it in an arbitrary fashion. I think the fact that Groovy has operators for this and can use them effectively is, again, partly an illustration that Groovy is nearly, what, 15 years old at this point? I mean, it's very mature. Of course, they have pretty much everything you'd be wondering about. Kotlin is still kind of new, and this was obviously not a high priority when they were creating the first versions of the library. Maybe it will develop it in the future. I don't know. I showed you the tail recursive example already. Groovy uses an AST transform. Kotlin actually defined a keyword. The AST transform mechanism is, of course, something that's easy to add to the library. They can add lots of AST transforms like memoize. It's kind of hard to wind up adding keywords to a language. But okay, that's what we have. Java doesn't have that at all, of course. Now, one thing I should mention about Kotlin is that while the language is evolving, of course, if you really want functional programming mechanisms, if you're really interested in functors and monads and everything, there's a library called Arrow, which is pretty much seems to be the definitive library for going to that layer. I have to say, I haven't really needed it. I mean, I can get where I want to go without going through stuff like that, but it is available and it's still evolving. And when you look into the terms functional and Kotlin together, you'll inevitably will get pointed to the Arrow library, which seems to really be the definitive answer on that. Now in Groovy, the nice thing about Groovy, of course, is that any Java library you want to use, you could just use immediately. You could just take advantage of it. You could use JSON, you could use JSON parsing, like I say, JSON there, just on and on whenever you like. So really the question is what Java library is available, although there are functional libraries for Groovy as well. I tend to think of Groovy as taking advantage of the whole world of Java and just making it better, if you will. Okay, couple other things and then a couple of bigger examples, and then I'll be happy to take any questions or comments or show additional code if you like. First of all, Groovy has both runtime metaprogramming and compile time metaprogramming. That AST transformation mechanism is compile time metaprogramming, but we have runtime metaprogramming also. We can change the behavior of classes at runtime. This is somewhat controversial. You know, it's something that you have to test, make sure you're okay, but I have a silly example, so I might as well use my silly example here. We close all these. My pirate example here. I'm using a RESTful web service at a place called funtranslations.com. And the idea here is in Groovy, every class has a property known as the meta class. So when you access the .meta class property, it's calling get meta class. And the nice thing about the meta class is you could define new methods that will be on that class. So pirate here is now going to be a method on string that takes no arguments. That's what the arrow with nothing to the left of it is indicating. And what does it do? Well, first I read my key because I had to register for this one. I mean, hey, you know, I spent $5 here for this month so that I could do this. But don't count on this one working indefinitely. Any rate, the idea is that I read the pirate key, this .text property will read the code in. I have my base URL. I take my query string will be the text equals, I take the delegate here is the string that I am invoking the pirate method on. That's the delegate property of the closure, if you will. I URL encode it in case it's got spaces or whatever in it because I have to pass it over the internet. I add in my key. This is a Groovy string that does interpolation. Kotlin strings do interpolation very similarly. There's a method in the Groovy JDK to convert a string into a URL. We'll parse it that way, and then this will retrieve the text from that URL. Groovy has a JSON parser built into it. Kotlin does not, neither does Java, interestingly enough, even after all these years. They call it a JSON slurper here, but there's also a parser. I can parse the text, and then I can return, this basically drills down on the JSON structure and grabs the value out of it. This is a case where I find using def to be useful because the compiler has no idea what the JSON structure is going to be. So it's not like the compiler knows that there's a contents property. It doesn't know any of that. Why do I care what the actual class is? I'm just navigating the JSON structure. This works for me. So at any rate here, let me execute this script and show you. Just had my power flash. Hopefully I didn't lose anything yet. Notice here, there's my pirate method that's converting all of these types. Even I'd like to add you to my professional network on LinkedIn. You see, this is the sort of runtime metaprogramming you can do in Groovy very easily. Whereas in Kotlin, what we have are extension functions. I referred to a couple, but here's another one just to give you an idea. So here's palindrome, for example. A palindrome, of course, is the same forward and backward, but only if it's all the same case and if you remove all the punctuation. So you can write a method like isPal here that takes a string, converts it to lowercase, replace the non-word characters with an empty string, and then use equals equals, which Kotlin, like Groovy, has operator overloading. Equals equals here is going to invoke the dot equals method. That's one way to do it. Here is what I would argue would be a more idiomatic way to do it. In fact, I would argue that this code right here, you could claim is speaking Kotlin with a Java accent. You know, it's kind of how a Java developer would write it. Here, this would be a bit more idiomatic. I convert the string to lowercase. See, notice that the method is being added to the string class. This is the current string, convert it to lowercase, do the replacement, and then there's one of those scope functions called let, which basically says, okay, after you've got this replacement string, let's execute the following block, which is to see if it is the same as it.reversed. And this scope function allows me to write the whole thing as a single expression implementation here. And I could look at my test here. I think my test is in palindrome tests here, and you could see I could check all of these, you know, a Santa pets rats as Pat taps a star step at NASA. This one's my favorite. This one goes on for 543 words, and yet it's a palindrome. You know, this is actually using the method instead of the function, but you could see they all seem to work. And there's extension functions in Kotlin. So nice little mechanism there too. I've got a prime number calculator as well. All right, I promised some cat pictures. So let me show you the cat picture implementation. This is not going to use Kotlin. It's going to use Groovy and Java together because I could do it all in Groovy, but I want to take advantage of Java parallel streams for no good reason. So let me show you what I'm going to do here. Oops, wrong one. Okay, now Flickr, if you remember Flickr back in the day, that was a good image site, and it's owned by Yahoo, so I actually had to get a key, and that was no fun either. So, I went through something here to show you this. Groovy, oh, did I lose it?
Yeah, I think you lost it.
Yeah, I think we lost Ken. Maybe we can wait a few minutes, see if he comes back.
Oh, look at that. I actually made it back in. I can't believe it. Sorry about that. You know, we lost power just as I thought. It just took a lot longer to allow me back into the system than I expected. Should I go ahead and finish that up?
I think like more than 50% of the people left, but if
Yeah.
it's being recorded, then yeah, by all means, then we can
Yeah,
just.
which I totally get that. I understand. I mean, I'll do the last section just to show it, but honestly, you know, I mean, after all, people who stayed, you know, they shouldn't, you know, I might as well show it to them if I have it, you know. Oh, I am sorry. That is a shame that happened that way, but that's all I have. So at any rate, what I was trying to show, you know, again, there's somebody typed in the group chat, they're still here. So let me show you what I'm doing here. I've got this Flickr API, and the idea here is I'm creating a query string from a series of parameters. So I'm writing it out in a way that's formatted a little bit just to show keys and values. Oh, someone said the best people are still here. Yes, the good students, right? Yeah, I can't blame anybody who decided to move on. Any rate, these are all keys and values. And in Groovy, when you make a map, because this is a Groovy map, then the keys are assumed to be strings already. So you don't have to wrap them in quotes or anything like that. They're already strings. So this is why the people who really like RESTful web services would be appalled. I mean, they actually have the method name embedded in the query string for Flickr. But whatever, I'm searching photos. There's my file name, or there's my key rather. I'm looking for JSON format. I'm going to use the tag, the search term cats, and I want 6 photos. That's what this is. So what this will do is allow me to build the query string. It takes all these parameters and it converts them all to map.entries. So the toString method on a map.entry is key equals value. So that's what this does. This will automatically produce a collection of key equals value elements. And then I join them all with an ampersand. So there's my query string. Then I plug in the endpoint, which is this endpoint up here, followed by the query string, convert it to a URL, and download my data. The data is in JSON format, JavaScript object notation. I can write it to a file in various pretty printed mechanisms, and then I can parse it. And what I really want out of it are sub-elements. See, the root element inside has an element called photos, and that has 6 photo elements inside it. And then the way Flickr works is that these photo elements have what they call farm and server and ID and secret of all things and titles. And you build up the URL for the actual image in this mechanism like this. So I take all the values out of the photo. This is a method to convert a photo element into an image. So this will allow me to build up the URL, and then I'm using ImageIO's read mechanism to download the image, and that will return, technically it returns a buffered image in Java, but I'm just using, that's a subclass of image anyway. So this method right here allows me to take one of these photo elements and convert it into an image. So to do the download in parallel, right now this is sequential, but let me make it parallel. Uh-oh. All right, so any rate, what I do is I call parallel stream, and this will say, let's take each element in that photos collection and use that photo to image method on it. So that will produce a stream of image, and then I collect them into a list. So this is the download in parallel. Now I got to tell you, it's not going to buy me anything. I only have 6 images, and even if I download them all simultaneously, it's fast enough to download them all sequentially. And whenever you do something in parallel, you add overhead. So really, if I compared it before and after, it's really not much of a difference, just to let you know. But at any rate, this will do it in parallel and get my list of images. And then this is a swing builder. This is a class from Groovy that allows me to go off the event dispatch thread and build a JFrame. Actually, that's on the event dispatch thread here. JFrame with a title. It's visible. I'll make it small. I build a layout with 3 rows and 2 columns. So there's my 6 images. If I close it, it closes the overall GUI. And then for each of those images that was downloaded, I'm making a J label out of it and wrapping that image inside an image icon. Now, I have to warn you, I don't know what I'm going to get back. I mean, I'm going to get the latest 6 images tagged at Flickr with the word cats on it. And in fact, I'm going to be a little bit careful here and run it on another window just to be sure I don't get something completely inappropriate. So it's doing the download now, or actually it's compiling now. The download happens very quickly. Oh, look at that. It came up on my main screen anyway, and there are my cats. I'm putting that in the win column. Those all look like cats. So, hey, that worked. So all these images, let me show you back on the code here. Let me bring this back. Notice in the code here that I'm actually, as part of the download, printing out the thread that's being executed for each title. So here are the titles and here are the threads. And when you use parallel streams with Java, you are, oh yes, thank you. Got the right comment. So when you use parallel streams in Java, what you basically do is by default use the common fork join pool, which is actually pretty good. It does work stealing and everything. It's very efficient. Now, again, these downloads are so fast that all the time it took to run this was basically in compiling and executing the code. The URL downloads were very, very quick. And you see, there are my titles and there are my workers. And again, if I just run it again, just to, now that I know that the cat images I'm going to get are not a problem, yeah, see how quick that is when it works. Now, Kotlin, interestingly enough, has a function built in where you could measure how much time it took to run and everything. But again, I don't really see much of a difference between that and if I just make it sequential again, just to show the difference here. So now it needs to recompile it, which takes an extra moment. But when the download happens, the download is quick. And there they are again. It's not like I gained, you know, not like I really have a difference. But notice these are all on the main thread as opposed to the other thread pool ones. And this is the JSON data coming out of it. All right, so there's your cat pictures. And I did this partly to do the parallel stream, but this shows that if I want to use something from Java in Groovy, I just use it. Now, if I did this in Kotlin, because I could do much of this in Kotlin, I would use coroutines to do the downloads in parallel, but there's nothing that I know of comparable to a Swing builder. I'd actually have to use an actual GUI library. You may know that the JavaFX library, by the way, can certainly be used in Kotlin. I've seen Trisha G, for example, do presentations where she puts a GUI on top of RESTful web services in a similar manner using JavaFX. I just don't know JavaFX well enough to pull that off myself. So I know it can be done. I just don't have a similar example of that. There are other examples in here, but basically the summary is that you can use any of these languages. Java goes as far as it goes. You know, it has map, filter, reduce, and a little bit of the composition, but not much else. It does have method references. This stream metaphor is something you do turn out to get used to reasonably quickly. But if you need to go beyond that, well, Groovy has lots of stuff. And it has its own AST transforms. It has things we didn't talk about, like traits, which are basically interfaces that have implemented methods in them. So similar to default methods in Java interfaces, but even you can do, you can actually have properties in them and more. They have these really nice builder classes. Kotlin has a few builder classes as well. So Kotlin has its own quirks too, but you just use each language for what it does best. So there's a question here. It says, why do you think Groovy is not widely adopted as functional programming language of choice in a corporate environment? Now, okay, and then the fiber question. So let me address that. Now, by the way, I'm leaving on here. There's the URL for the GitHub repository. I will commit my changes that I did after we're done today and push those up there. So actually, I should go back to the beginning so that you can see my contact information in case you want to get a hold of me. That also has the URL here. All right, so addressing that question. Oh no, we just had a bit of a brownout again. Hopefully I'm still with you in this case. Yep, I think I'm still in there. So I think part of the reason it didn't get adopted in a widespread fashion, part of it was the fact it was called Groovy and names matter. And it was hard to convince the Fortune 500 to use a language named Groovy. I think that's a small impact, but it's an impact. I think the fact that it was supported by Pivotal, and then when Pivotal decided no longer to support it, they made a big deal out of it and really announced it loudly to the world. And even though it's now an Apache project and it's moved on, and in fact, Grails is better supported now than it ever was back then, that effectively hurt it. I think another thing, which is a really interesting problem, is that they say that your best feature is sometimes also your worst feature. And the people who are at the top in the Groovy framework, people like Graham Roche on Grails or Guillaume Laforge or Paul King on Groovy, are among the humblest people I've ever met. So they're really wonderful to work with, but they're not good at publicizing themselves or the language. They give talks all the time, sure, but it takes a certain arrogance to really get attention, to claim you're better than everybody else. And those three people that I mentioned don't have an arrogant bone in their body, at least not my observation. And while that makes them wonderful to work with, I think that also contributed to people just not adopting it. Another interesting side point is that Groovy success stories are really Java success stories. I've never seen a Groovy system beyond a trivial size that didn't already have Java in it too. Groovy is really more of an integration language than its own. So I think that, again, it's hard to publicize these big Groovy success stories when in fact they're Java success stories that have Groovy classes in them as well. So Grails was quite successful for a while, but as a lot of what our web development turned into web service development in the industry, I think as that happened, that became less important. Now Micronaut is a fantastic system for building RESTful web services, and that came out of the Groovy ecosystem, but you can use Micronaut with Groovy or Kotlin or Java, frankly. So again, is it really pushing you in that way? And then Gradle, which was another offshoot of the Groovy ecosystem, wound up adding a Kotlin DSL, even though it doesn't seem to be all that extensively used, it's available, again, diluting it. So these are all opinions, feel free to agree or disagree with any of them. The other comment about Java Fibers, I've heard Brian Getz actually say they're going to put Kotlin out of business when Fibers come along, because coroutines are really lightweight and do a lot of the same things that Fibers do. Yeah, I'll believe it when I see it. I think Fibers are going to be awesome, but the truth is that Fibers are not going to be around until at minimum Java 17. And how many companies do you know are still on 8? So it's one thing to get them to move to 11. It's going to be 17 will be the next long-term support version, and maybe Fibers will be the reason to upgrade. We'll see. I think it's going to be years. Whereas if you want to use coroutines, you use it tomorrow with Kotlin. So I think Fibers will make a big impression. I think the Kotlin people are not exactly sitting around. I mean, they're watching those developments and they're taking advantage of all those features now. So I don't think there's any reason to have to wait, but we'll see. I also hope that, as the person said, that Micronaut will see the success it deserves. I honestly, I think Micronaut has done brilliantly. I really think it's a great job. Another one, widespread adoption of Kotlin in the mobile world, right? And in general, Kotlin is a much better Java than Java, or much better than Java, which is verbose and NPE prone, right? What do you think about Java's future? I think that Java improved enormously when the functional features were added in Java 8. It really cut down on the level of verbosity. It also made it feel simpler and more practical and more relevant. I think the people who are working on Java now are very bright people. I think a lot of the features that they're talking about adding in 14, things like what's out now, the enhanced switch statement, which is again something that Kotlin has and Groovy has. I think the records are going to be nice. I think Java's still doing fine. And there's a lot of companies who are like, well, we're already with Java, we'll just stick with it. I think they'll be okay. When you look at the percentage of users of Kotlin versus Java versus Groovy, let me put it this way. Java has a huge install base and a huge number of developers. And if you look at just surveyed the jobs available for Java people versus Groovy, Kotlin, Scala, Clojure, all of them, they all become noise compared to the number of Java people out there. So it's nice to see these things, and the Kotlin and the Groovy and other communities are very active, but we're talking about a mountain. You know, these are tiny implementations compared to a giant, you know, and we'll see. I think Java is going to do fine. I don't think it's going away. I don't think people are going to abandon it. I think that all these alternate JVM languages are kind of competing among each other, really, more than they are with raw Java. But I do think knowing them will really help, and eventually innovations that happen in those alternative languages eventually filter their way into Java itself. The Java team is very conservative about that. They're very careful. Yeah, like COBOL's going away, as Bill said. Yeah, exactly. You know, there's 4 trillion lines of COBOL still in execution today, you know. So at any rate, I like Kotlin. I like it as an Android language. I enjoy working with it. It does have some different idioms, which took a little bit of getting used to, and I like that. Will they become definitive for multi-platform? Are people going to be writing, you know, iPhone apps in Kotlin? We'll see. I do like the fact that Spring is very fond of both Groovy and Kotlin. You can write Spring apps in Groovy, you could write Spring apps in Kotlin. And the thing that's good about it is now we have a path. Like all those Android developers who are building their app want to talk to the server side. And if they already know Kotlin because of Android, they're going to want to use Kotlin on the server side, and Spring is there waiting for them, saying, sure, build a Spring Boot app, or as we know, build a Micronaut app directly in Kotlin, and we'll see. That's a mechanism that I wouldn't be surprised turns out to be very favorable for the future. Any other questions, comments, words of wisdom? Heard any good jokes lately? You know, anything else in there? Well, I'm really glad. I'm sorry we had that interruption in there. I mean, it's really annoying. I haven't had problems like that in a while. We just happened to hit the one day where the hurricane was passing through. I'm glad I was eventually able to make it back in, even though I was delayed a while. Again, you've got my email address. Feel free to keep in touch. You know, send me messages or whatever. My policy on LinkedIn invites is I agree to everything that isn't obviously a recruiter or trying to sell me services or something, you know, and feel free to take a look at the newsletter. Okay, great. Yeah, again, I'm around if you have questions. I don't have some pressing engagement, but I know people are going to be interested in moving on, so I don't want to hold you here if you've got other things to do. But I will say thank you very much for the invite. I'm really glad I was here. We do have a bit of recording, although I guess it'll have a gap in it for me. I don't know how much, I don't know if this part's made it into the recording or not. But otherwise, thank you for coming, and I enjoy the London Java community. I'm just keeping an eye on the group chat in case there are any last questions. Yep, cheers, as I said. I think I can probably turn off the screen share though. Oh, no promo code? You know, I would think I would have one, and I don't, and I probably should have asked O'Reilly for that, but they don't normally give out promo codes. They do sometimes raffle off books though. I should probably contact somebody. Sorry about that. That would have been a good idea. Somebody sent me a really bad joke. Yeah. I should give you the worst SQL joke ever told for those people still here. The worst SQL joke ever told. SQL query walks into a bar, selects 2 tables, says, mind if I join you? Yeah, there's no coming back from that one, is there? Although there is a NoSQL variation. DBA walks into a NoSQL bar and can't find a table, so he leaves. Yeah. Sorry, but not sorry. I think one of the organizers had to leave. Who's running things now? I don't know. I think we are recording still. So, because of course I was the one who left, not you. So I guess the recording will work. All right. Well, thank you all very much. I'm going to take off there. And again, feel free to keep in touch. So good luck and stay safe. Yeah. Bye-bye.